Hi everyone, this video is going to be a quick solution of this problem that we did not get a chance to do in class on the 15th, on Wednesday. It involves a skateboarder going through a loop in a pipe, and we want to find the minimum speed that they must have at the very top in order to make it through the loop. Let's actually while we're thinking about this, let's talk about the skater at the bottom of the loop first. This isn't the question that's being asked, but we can practice drawing a free body diagram and just looking at what happens to the normal force at the bottom of the loop for this skateboarder. So let's take this here and let's just draw a cartoon first of what this skater looks like. So we have our skateboard here and a skateboarder on it, and they're traveling through the loop with some velocity like that. So at the bottom they have an instantaneous velocity. They're coming down, going to the right, and then going up. The free body diagram for this scenario, we'd have our skateboarder. We know they have a weight down, so we have a gravitational force down. And we know that if their velocity is coming down and going across and then going back up, they must have an acceleration pointing up, right? We know that our acceleration must be up. Well, if I have a downward weight force, I know that my upward normal force must therefore be bigger in order to have this downward force. So my upward normal force must be larger than my weight force. Then if I were to write a free body or a Newton's law expression based on that free body diagram, I would choose positive x to be in the upward towards the center of the circle, right? Always positive x towards the center of the circle, so that the sum of forces in the x direction, that's going to equal my normal force minus my gravitational force, and that's got to equal mass times the acceleration in the x direction, but again that's centripetal acceleration. So I would have the normal force is going to equal, let's write normal force minus mg equals mv squared over r, where r would be the radius of my circular path. If I want to just solve this for the normal force in order to make a comparison when we actually solve the question that's being asked, this would just simplify to the normal force is equal to my centripetal force mv squared over r plus mg. So we see no matter how fast I'm going at the bottom of this loop, no matter how fast I'm going, I'm always adding something to my weight. So I always feel, in finger quotes, I always feel heavier. My apparent weight, which is the normal force, my apparent weight is always bigger than my actual weight, just given by mg. Let's solve the question that we were actually asked for. So I'm just going to delete all this stuff that we just did. So I'm going to be able to draw a cartoon and a free body diagram for the skater at the very top, at the very top of the loop. So now the top of the loop looks like this. We're the skateboarder and we wish to be going through the top upside down. We've made some poor life choices, and here we find ourselves in this position. We are hoping that we have a minimum speed big enough so that we can continue through the top. So my velocity at that instant is there. My acceleration, again, at that instant must be towards the center of the circle. We're going to assume that we are traveling with uniform circular motion, so we have an inward acceleration. That also informs my choice of x being positive towards the center of the circle again. My free body diagram in general looks like the following. We have here our weight down, so there's our gravitational force down. That's our weight, F sub g. And then we also have a normal force down, right? A normal force pointing from the track onto our skateboard. That normal force can be any size depending on the speed with which we are traveling through the loop. And since we are asked for the minimum speed, let's first work with this to decide what that minimum speed would represent. So we have an equation in the x direction saying that the sum of forces in the x direction is going to be now my gravitational force plus my normal force, and that's got to equal mass times acceleration, where acceleration is written as v squared over r. So here we can see, okay, as my weight stays the same, as my velocity increases, something has to increase over this side, so that's going to be my normal force because my weight is staying the same. So that means that my velocity can get smaller and smaller and smaller until that threshold where my normal force goes to 0. So as Fn goes to 0, that is my, what I'll say is v critical, my critical speed, my minimum speed to go around the top of my loop. So that means to actually solve the question of what that minimum speed is, I'll choose the scenario where my weight is equal to my m v squared over r, my mass times acceleration. Again, that's basically just saying that the force that is causing this skateboarder to go through uniform circular motion is just their weight. When I am going faster, I have both the weight and the pushing normal force of that skateboard pipe on my skateboard, of the bottom of the pipe on my skateboard. That is also helping me maintain that uniform circular motion. At a slower speed, that cutoff is where just my weight is allowing me to move in a circle. If I go any slower, I can't move in a circle. My weight is not the right size to move in a circle, so I don't move in a circle, and in fact, I drastically change the radius of my circle, which is actually bad news when I'm upside down. This is the path where I'm drastically changing the radius of my circle, also known as falling. So if we were to solve this for v, we would put in the values that were given. 14 feet turns out to be something like, oh, I had it written down and I don't have it with me. Excuse me while I shout into my phone. What's 14 feet in meters?
14 feet equals 4.267.
4.27 meters, 4.267 meters. So we would convert this to actually use it in R, but if you do that and you check your calculation yourself, you should get that my speed, my minimum speed that I can have is 4.57 meters per second. And again, converting 14 feet, that's also the diameter, so you'll have to cut it in half, but this is the answer that we get when you take this 14 feet, convert it into meters, you get 4.26, whatever my phone just said. Divide that by 2, that's the radius of my circular path, and then we're off to the races.